All right, this lesson is 4.2.1, and it is unmanned systems. So really in this lesson, you're going to learn what an unmanned system is, the environment that they operate in or environments they operate in, and the history of unmanned systems. Okay, so obviously an unmanned system is a system without a human on board, so the human factor is reduced significantly. And system operations are controlled by a remote human or a processor that is capable of interpreting inputs and establishing proper outputs. So these are not necessarily fully asynchronous devices. They can also include remotely operated, teleoperated systems which require direct human operation. Okay, so really the human factor, except for completely autonomous systems, is not fully eliminated. So in general, unmanned systems are those that do not include an on-board human. So that means that they can either be partially remotely operated or they can be completely autonomous without human intervention. Okay, there's three key environments that unmanned systems operate in. That would be the air. So we refer to those as unmanned air vehicles or UAVs. We have ground, which is unmanned ground vehicles or UGVs. And then we have our maritime. So that's unmanned maritime systems or UMSs. Really, when you're looking at an unmanned system, there are key design components that you have to have. So first, we're looking at the operational environment and its tasks. So the environment is defined as land, water, or air. And then we have to clearly define what task we want the system to accomplish. And then we have to decide how it's going to sense its environment. So decisions must be made regarding which aspects of the environment are important for decision making or data collection. So for example, if we are in the air, how do we detect whether there's a bird nearby? Okay, and then an appropriate sensor has to be implemented in the remote system designed for each aspect. So for every piece of data that we need in order to be able to complete the task, we need a sensor that's going to appropriately collect that data. In addition to that, we have to have a piece that identifies communication so that information can be passed to and from the remote system actively throughout the mission or can be stored for processing prior to launch and then after recovery of the system. We also have to deal with information processing. So we can either have the data be left as numerical values, so like binary zeros and ones, or processed into charts or graphs, or analyzed for statistical patterns like mean, median, mode, standard deviation, etc. It just depends on the task that they are trying to complete. We also need to have an energy source. So we have to have the energy on board the system. So it can be a battery or has to be produced by the system. So that can be a fuel cell or burning a fossil fuel, or it has to be gathered by the system. So that would be a solar or laser light conversion from an external source. And then we have to transfer that energy from the source to create the mobility of the system or actuation of the components of the system. So any kind of manipulator, a claw, a camera, anything along those lines. So unmanned systems have actually been around a lot longer than you probably think. The first unmanned system that can be identified was actually in 1888 from Louis Brennan, and he actually demonstrated a wire-guided torpedo. And then in 1898, Tesla introduced teleautomation, which was a 4-foot-long boat, or teleautomaton, my bad, a 4-foot-long boat that could start, stop, and turn using radio frequencies. So why was the first unmanned systems maritime systems? Well, that was really because at that time naval warfare was a significant focus for military strategists. So that's kind of where the money was going. So looking at the teleautomaton from Tesla, he really needed to understand the operational environment and the task in order to be able to create his unmanned system. So he had to have a really significant knowledge of buoyancy, materials, and the structures. He also had to know the laws of motion, because when you start, stop, or turn on a command in water, things happen a little bit differently versus in the air or on the ground. His energy source was an electric battery, which was pretty novel for the time, and his energy transfer was electric to mechanical. So he had an electric motor that transferred that energy to the propeller and made sure he utilized the laws of motion. And then in addition to that, for communication, he used that radio frequency transmission to receive his signals. And then he had switches that were triggered by direct communication. So he would flip switches that would then send the frequencies to the boat to be able to turn and move forward as needed. So looking at the first unmanned aircraft system, we're looking at about 1915, and it had limited success because we were lacking technology in 1915. And so we had to really look at flight concepts and how to get automatic stabilization and autonomous navigation. We also really were limited on petroleum fuel and electrical batteries at the time, which really limited the ability for us to have an aircraft system. So realistically, what we ended up using at that time was pneumatic parts from organs that were operated as mechanical parts. And we had a lot of high weight, low power engines, unfortunately. So we could still use the radio frequency transmission, just like Tesla had. But realistically, we were looking at some limitations for information processing because we had to perform that by the operator. Now, this is in comparison to today's unmanned systems, where technological advancements have pushed unmanned systems and development. So we're looking at more versatile, adaptable, and persistent systems in civil and commercial areas, recon and combat, logistics, research and development, target and decoy and exploration. So there's a lot of unmanned vehicles that are out there today, and that's really the focus of your lesson and activity for unmanned systems.